So now we are on next section, which is running a basic contract. Write our smart contract. Pick your favorite code editor and open our directory. When you set up your local environment, we have already set up it. Now let's delete the log.js and delete deploy.js, and then delete all the under contracts. Don't delete the actual folder. Okay. Now let's delete the files here. Uh, yeah, delete the log.js, cited test folder, and also delete the contract here, as we are going to create a new contract. Okay, now let's get to writing our FT. If you have never written a smart contract, don't worry, just follow along. Google stuff you don't understand, ask us in Discord. Okay, so you can see my previous tutorial of buildspace.so, or check other smart contract of how to write a smart contract for uh, further understanding of a smart contract. So now create a new file, myepicgame.sol. Let's see here. Let's create a new file. Okay. File structure is super important when using hard hat, so be careful here. I want downloading Solidity extension uh, for VS Code, which gives a nice syntax highlights. Let's see. I think we already have it or not. Just check it. Yes, I've already installed it, so you can also add this extension. Okay. Now let's see. Let's write a basic smart contract here. Here it is. There's a basic smart contract here with the name my epic game constructor and console.log. Importing a hardware.console.sol file in order to access this. So VS Code itself will throw errors that aren't actually a problem. For example, it may underline the hardware import and say it doesn't exist. Here it's showing that. This happens because your global Solidity compiler isn't set locally. If you don't know how to fix it, don't worry, ignore this for now. Also, I recommend that you don't use VS Code terminal. Use your own separate terminal. Sometimes the VS Code terminal gives issue if the compiler isn't set. Let's go line by line. This is a license file, just fancy comments. It's like a file. Feel free to read it for this. Pragma Solidity. This is a version of Solidity compiler we want to contract to use. Basically says when running I only want to use version 0.0 0.8.17 for the compiler, nothing lower. Note: be sure your compiler is set to 0.8.17 config. Let's see. Here it is. Yes, it's set. Some magic importing this file. The magic is by hard hat to do some console log in our contract is actually challenging to debug smart contract, but this is one of goodies. Hard hat gives us to make the life easier. Okay. So we will have a function console.log by importing this file. So this is very useful when we're debugging a smart contract. So smart contract can look like class in other languages if you have ever seen those. Once you initialize the contract for the first time, the contract will run and print out the line. Please make sure that the line say whatever you want. Have a little fun with it. Okay, let's change it. Now how do we run it? We have got a smart contract, but we don't have it works. We want actually compile it, deploy to a global blockchain. Once it's here, the console log will run. We are just going to write custom script that handles those three steps for us. Go into the scripts directory and make a file named run.js. Okay, now let's create a new file run.js here. Let's copy this code and paste it inside run.js. There it is. Okay, so now see how it's work. There it is. VS Code might auto import ethers. We don't need to import ethers or anything, so make sure not importing anything. Go to import to make sure not to import anything. Again, going line by line here. Game contract factory is equal to await cherry contract factory my pick. This will actually compile our contract and generate the necessary files we need to work with our contract under the artifacts directory. Go check it after you run this. We have run the last time, so there is a log.json file. So let's run the new contract and then see again. Okay, wait to deploy. It's very fancy. What happens here is the hard hat will create a local Ethereum network for us, but just for this contract. Then after the script completed, it will destroy the local network. So every time you run the contract, it will be fresh blockchain. What's the point? It's gonna like refreshing your local server every time, so you always start from a clean slate, which makes it easy to debug error. So game contract dot deploy, there it is. Well, wait until our contract is officially mined and deployed to our blockchain. That's right. Hardhead actually creates a fake miners on our machine to try its best to imitate the actual blockchain. Our constructor runs when we actually are fully deployed. There it is. Finally, once it's deployed, game contract dot address will basically give us the address of the deployed contract. There it is. This is how we actually find our contract on a blockchain. Right now on our local blockchain, it's just so that isn't that cool. But there are millions of contracts on the actual blockchain, so this address gives us easy access to the contract we are interested in working with. This will come handy when we deploy to the actual blockchain in a few lessons. Okay. Before running, make sure the solidity in our hardwareconfig.js. Yes, we have already checked it at 0.8.17, the version that we are using, the compiler version that we are using. Let's run it and open in terminal like that. Okay, now let's run the script. So here it is. We got the message, hello Pokemon game from our smart contract, and there is a message under deploy to, and this is our contract address. So that's it. You should see your console.log run with the contract, and then you should also see the contract address in order. Yes, let's see. Edge hardware and HRE. In this code blocks, you constantly notice that we use HRE.ethers, but HRE is never imported anywhere. What type of sorcery is this? Here it is. You can see that we are using HRE, but we not import anything like that. So what it is? Directly from the hardware docs themselves, you will notice this. The hard hat Ethereum runtime environment, or HRE for shorts, is an object containing all the functionality that hard hat exposes when running a task, test, or a script. In reality, hard hat is the HRE. So what does this mean? Every time you run a terminal command that starts with npx hardhat, you are getting HRE object built on the fly using hardhat.config.js specified in your code. This means you will never have to actually do sort of import into a files like this. So so every time you run a terminal command, then start npx hardhat, you are getting this HRE. So we will get HRE by default, so we don't have to import it like that. So we'll be seeing HRE in a lot of code but never import anywhere. Check out our documentation to learn more about it. So for a screenshot in progress with the output of, now let's take a screenshot of our output. Let's take snippet and save it here. Now let's submit the requirement here. There it is. So we have submitted here. Now let's move on to the next section. So it's submitted successfully.